You write a script, you try to run it, and you get permission denied. So you do this, chmod 777, it works, and you move on. But do you know what you just did? Or what those strings of letters on the left are telling you? Why can you delete a file you can't read? Why does execute permission on a folder matter? What setuid, and why is it dangerous? 9 bits. Learn to read them, and all 3 answers are right there. Start with the thing we're protecting. Every file on Linux has an inode. The inode is the file's record, size, timestamps, who owns it, and who's allowed to do what to it. A file has exactly 1 owner and exactly 1 group, and 3 sets of permissions. 1 set for the owner, 1 for the group, 1 for everyone else. Open a file and Linux walks that ladder in order. Are you the owner? Owner permissions. In the group, group permissions. Neither, and you get whatever's set for everyone else. Only 1 set ever applies, the rest of the ladder is never tested, first match wins, and Linux stops looking. Say a file gives the owner read-only and the group everything. You're the owner, and you're also in that group. You still get read-only. Owner matched first, so Linux never looked at the group permissions. On a file, read lets you look inside. Clear that bit, you get a denial. Set it, and the file comes back. Write lets you change what's in there. Append a line, and the file grows. Clear the bit, and nothing happens. Execute lets you run it as a program, which leaves that second command, one that ran with no X bit set on the file, needing an explanation. Execute is only needed when you run the file directly. Put the interpreter in front, bash, and then the file, and read is enough. Bash is the program being run. Your script is just a file it reads. Same with Python. Run the file alone and it needs execute. Put Python in front and read is enough. Same rule, different interpreter. Compiled programs are different. There's nothing to put in front, so the kernel reads the first few bytes and loads the file itself. A binary always needs execute. So those 2 commands were never a contradiction. There are 2 different gates, and only one of them was ever on your file. You've typed chmod 755. What do those 3 digits mean? 3 digits, and they line up with the 3 sets you just saw. Owner, group, everyone else. Each permission carries a number. Read is 4, write is 2, execute is 1. Add up the ones you want, and the total is the digit. 4 and 2 and 1 is 7, so 7 is all 3. Every digit you'll ever type is some subset of that sum. 6 is read and write, no execute. 5 is read and execute, no write. 0 is nothing at all. So 755 gives the owner all 3, and read and execute to everyone else. The digits and the letters are 2 ways of writing the same thing. 755 is the standard for anything you run. Everyone can run it, only the owner can change it. 644 is the same idea without the running. 700 and 600 shut out everybody but the owner. SSH keys live in that territory. And 777, that's every account on the machine, granted everything. It's rarely a fix. It's usually a guess that happened to silence some error. A directory isn't a box that holds files. It's a table of contents, names on one side, inode numbers on the other. Nothing else is in there. The directory holds the names and the numbers. The file itself lives somewhere else entirely. Which is why read, write, and execute do something completely different on a directory. Read on a directory gets you the name column. Run ls, and there they are. And names are all you get. Without execute, you can't reach the inodes. So ls-l has nothing to put in the other columns. Those question marks are the command admitting it can't see. Execute on a directory is permission to go through it. cd into it or open a file inside it, provided you already know the name. So with execute but no read, you can't list what's in there, but you can open a file if you already know its path, a door with no sign on it. You can walk in, but only if somebody told you it was there. So execute is a gate on every folder in the path. Open a file, 3 folders deep, and you need it on all 3. Miss one, and you can't get to the file. File's own permissions never get read. Write on a directory is permission to edit the table. Add a row, remove a row, or rename one without touching what it points at. So you can delete a file you're not allowed to read. Deleting never touches the file. It takes the name off the list, and the list belongs to the directory. You need no permission on the file at all. Write on the parent directory is enough. So on a directory, read is the list, write is the table, and execute is the way through. Same 3 letters, 3 different jobs. 755 on a directory lets anyone list it and open what's inside. 700 stops everyone but the owner at the gate. Back to where we started. Permission denied. Let's work out why. We'll check 4 things. First, does the file have execute at all? Run ls-l and look for an x. If there's no x anywhere in that string, nothing will run it. chmod plus x adds it. Or chmod 755. Second, can you actually reach the file? You need execute on every directory in the path. Check them with ls-ld. Third, does the script have a shebang? The first line should read #bin/bash or #user/bin/env-python. Those 2 characters tell the kernel which interpreter to hand the file to. Without one, the kernel treats the file as a compiled binary. It isn't one, so it gives up. From a shell you may never notice, because the shell catches that and runs the script itself. From cron, or from anything that isn't a shell, nothing catches it. It just fails. Fourth, is the interpreter path right? #bin/bash only works if bash really lives there. On some systems, it sits at /user/bin/bash, and the shebang points at nothing. Point it at env instead. #user/bin/env-bash, and it finds bash on your path at runtime. One more, and it only bites if you edited the file on Windows. Windows ends every line with an extra carriage return, and that byte lands inside the shebang. So the kernel goes looking for an interpreter called /bin/bash, plus 1 character nobody can see. There isn't one. Run -unix on the file to fix it. 5 checks. In practice, it's almost always the first one. Here's password on a real system. Where the owner's execute bit should be, there's an S instead of an X. That 1 letter is the setuid bit. Run a program and it runs as you. Your user ID, your permissions. With setuid, the program runs as the file's owner instead, not as you. Password is owned by root and has setuid set, so it runs as root no matter who starts it. That's how you change your own password when the file that holds it, /etc/shadow, is completely off limits to you. The program carries access you don't have. Which is also the risk. A bug in a setuid program is a bug running as root. That privilege doesn't stop at the program's edge. That's why these get audited so hard. chmod 4755 sets it, a 4th digit, in front of the 3 we already discussed. Setgid is the same idea for groups, handing the program the files group instead of yours. On a directory, setgid does something else entirely. A file created inside a setgid directory takes the directories group, not the group of whoever created it. New subdirectories inherit the setgid bit as well. Set a shared folder to setgid and give it the team's group. Every file in it is now owned by the team. Nobody has to remember. chmod 2775. The 2 is setgid. Then set the folder's group. One more, the sticky bit. That's the T on the end. Look at /temp. Every user on the box can write to it. That shouldn't mean every user can delete your files. Without the sticky bit, write on a directory is permission to delete anything in it, including files that aren't yours. The sticky bit narrows it to the file's owner, plus root and the directory's owner. Anyone can still add files. Only the owner takes them away. chmod 1777. The 1 is the sticky bit. It's already set on /temp and /var/temp and on shared folders. So a full chmod is 4 digits with the special bits out in front of the owner, group, and other bits. A script you want to run, 755. Everyone can run it, only you can change it. A config file with secrets in it, 600, and nobody but the owner gets to read it. An SSH private key, 600 as well. Get this one wrong, and SSH won't argue with you. It just ignores the key. A shared team directory, 2775. Setgid, so everything created inherits the group. A public upload folder, 1777. Sticky bit. Anyone can add, only the owner can remove. Files a web server hands out, 644 for files, 755 for folders. The server can read them, only you can change them. If you're reaching for 777, read the mode first. 6 of those 9 bits are about people who aren't you. Quick recap. Every file has one owner, one group, and 3 sets of permissions. Linux takes the first set that matches you and stops there. On a file, read is see it, write is change it, execute is run it. On a directory, read is list, write is add or delete entries, execute is go through. Then the special bits. Setuid changes who a program runs as. Setgid sets the group on new files. Sticky decides who can delete. Know why each one is set before you set it. When a script won't run, check execute bit, directory permissions, shebang, and interpreter path. If this helped, please subscribe. Thanks for watching, and see you in the next one.